In this video, I will demo what you can do with the Docker Slave plugin that Nicola and I wrote during Docker Global Hack Day. So I have 4 different jobs to see what you can do. The first job is a freestyle job, which will build the Game of Life project. Let's see this configuration. So this job is set up to run inside a build container using the official Maven image. So this image is a standard image with no configuration specific for Jenkins. In this job, I will check out the GitHub repository of the Game of Life project, and then I will build it using a shell step invoking Maven. Let's build this job. When I start this job, a new Docker container is provisioned. Here we can see that it is running, which only contains the remoting part of Jenkins for the slave, and the checkout is running on it. When git finish, the build starts, and there is a new container which is provisioned from the official Maven image. So here we can see that there is 2 images running, 2 containers running. The build container only contains the Maven process, so we will see it using Docker exec. So here we can see that the first process of the container is the shell script created by Jenkins and the Maven process. In this container, you can see that the Jenkins user ID and group is correctly set up, because at the beginning at the creation of the container, we changed etc password and etc group files. So here you can see that there is an existing Jenkins group and there is a Jenkins user. A little better like that. As Docker is managing the process, you can see the logs of the running build using the docker logs command. And here you can see that the build is running. At the end of the build, you can see that there is not any container running anymore, but the container containing the remoting side is still here because we are keeping the workspace content for the next build. If I start a new build of this job, it will be much faster. So here we can see that Maven don't download all dependencies again because the workspace is cached. At the end of the build, there is still only 1 container. The next job, Maven Game of Life, also built the Game of Life project, but using a Maven job instead of a freestyle job. In the configuration, we can see that the build will run in a container using the official Maven image, that we will check out the same Git repository, but instead of running Maven manually using a shell step, we will use the Maven plugin, which integrates Jenkins with Maven. When we run the build, a new slave container is provisioned, and this container is different from the container of the previous job. can see that there is 2 slave containers. So for each job, the workspace is completely isolated. When Jenkins runs the build, it creates a new container, like before. And now we can see that we have 2 running containers. And we can see the logs here again if we want. For this job, Maven integration from Jenkins used the network stack to talk between the remoting and the Maven agent. And even if there is 2 different containers, it works because the network stack is shared between containers. At the end of the build, like before, container building the slave is disposed and the container with the slave remoting is still there. The third job is a very simple Maven job which will use a Selenium WebDriver to run tests in a web browser. So for this job, I run my build inside the Maven official image, but I also added a side containers containing Selenium with a WebDriver, which will be available on port 4444 from the network stack of my containers. This job, check out a simple demo, and I will run the test using the Maven plugin. At the end of the build, I will archive a screenshot of the web browser. Let's run this build. This job will be much faster because there is less dependencies to download. In Docker, here we can see that there is now 3 running containers. The remoting one, containing the workspace, a Selenium container, and my build container here. So here, the Java test is connecting to the web browser that is given by the Selenium container. At the end of the build, I have my screenshot, which is archived, and we will see here that we have a screenshot of the test. There is not any running container anymore. So here I demonstrated that it's possible to add side containers and that it's quite easy to use Selenium. In my last demo, I will build a PHP project using an image made from the official PHP Docker image, and I will install Composer on it, and I will run Selenium. There is a simple shell step which launch PHP unit. Let's run the build. So here I install Composer, and then I will launch the test. So on this demo, we can see that there is an error because the GitHub page changed. I reused an old demo of PHP using the Selenium WebDriver, but we can see that it was possible to connect to Selenium, and it's quite easy to run Selenium tests using our new Docker plugin. That's it.